Good day, grade 9 students. How are you? Welcome to this video lesson. In this video episode, we will discuss electron configuration. You are expected that at the end of this video, you must be able to write electron configuration and draw an orbital diagram of some elements. And before we proceed, let us have first a short review regarding Niels Bohr model of an atom. Class, let us first recall the total number of electrons that can occupy in a given energy level. What do you think is the formula that is being used in calculating the total number of electrons? Okay, if your answer is 2n squared, then you are right. Okay, where n represents the energy level. Now, can you calculate the total number of electrons in a given energy level? Okay. So, if you answer 2, 8 in the second, 18 in the third, and 32 in the fourth energy level, then you are correct. Okay, why 2? We simply square 1. Okay, we square 1. That will be 1 times 2. We arrive at 2 electrons. And in the second energy level, if we will square 2, that will be 4 times 2. And that is equivalent to 8. And if this is third energy level, we square 3. That will be 9 times 2. And that is equivalent to 18 electrons. And in the fourth energy level, we square 4. That will be 16 times 2. And that is equivalent to 32 electrons. Okay? Are you reminded already of the total number of electrons by energy level? Okay, very good. Okay, now let us compare atom with that of community. So if community is composed of different barangays, a barangay is composed of different purok, and then purok is composed of different houses where we can find families. In the same manner, atom is composed of different energy levels. And its energy level is composed also of sublevels. And that sublevel is composed of different atomic orbitals. So in atomic orbital, this is where we can find the electrons. In other words, atomic orbital is a region or space around the nucleus of an atom where we can find the electrons. Okay, now let us determine the number of sublevels in a given energy level. So it's just easy to memorize because the number of sublevels is just equal to the quantum number of that energy level. So, meaning if it is in energy level 1, we only have one sublevel. Energy level 2, we have 2 sublevels. Energy level 3, we have 3 sublevels. And in energy level 4, we have 4 sublevels. And with regards to the name of the sublevels, usually it is taken from the characteristic of light. So we have SPDF. We have SPDF. In the first energy level, the sublevel is only S. In the second, we have S and P. In the third, we have S, P, and D. In the fourth, we have S, P, D, and F. Okay? Okay, by the way, S represents sharp, P, principal, D, diffuse, and F, fundamental. Okay, let us now proceed to the number of orbitals in a given sublevel. So in the S sublevel, usually we only have one atomic orbital. So even if it is in energy level 2, still we have one S orbital. And P has 3. Usually the pattern is plus 2. So 1 plus 2, we have 3. So 3 p orbitals. Same manner also in the third energy level, we have 3 p orbitals. And also in the fourth energy level. And again, in the D, 3 plus 2 is equivalent to 5. Same with in energy level 4. Okay, so how about in F? If we will plus or add 2, and this will become 7. 5 plus 2 is 7. 4, 5, 6, and 7. Okay, then, since this is already an atomic orbital, we can now determine the maximum electrons that can occupy in a given orbital. What do you think? Okay, we only have 2 electrons, and the 2 electrons have opposite spin, the clockwise and the counterclockwise. We do the same with the other orbitals. So let's just write 2. Assuming we already write 2 electrons in all of these orbitals. So, okay, let us total all the electrons in a given sublevel. So, in sublevel S, we have total of 2 electrons. In P, we have total of 6 because we have here 3 atomic orbitals having 2 electrons. And in D, we have 5 orbitals having 2 electrons, a total of 10 electrons. And in F, we have 14 electrons. And if we will count totally in a given energy level, so in the first energy level, we have only 2 electrons. In the second energy level, we add 2 plus 6. That is equivalent to 8 electrons. And if we will also total the electrons here in the third energy level, that will be equivalent to 18 electrons. And of course, here, if we will add, that will be equivalent to 32 electrons. So far, those are the number of sublevels, the number of orbitals, and the total electrons in a given sublevels and orbital. Okay, to summarize, class, we have here table of quantum number in relationship with atomic structures. So we have here principal quantum number 1, 2, 3, 4, meaning to say energy level 1, energy level 2, energy level 3, and 4. And these are the sublevels. Energy level 1, we have S sublevel, number of orbitals 1. Okay, and the second, SP1S and 3P. The third energy level, we have SPD, 1S, 3P, and we have 5D orbitals. And in the fourth energy level, we have SPDF, 1S orbital, 3P orbitals, 5D orbitals, and 7 orbitals. So we have here the number of orbitals per main energy level, which has the formula n squared. So meaning energy level 1, we only have 1 orbital. Energy level 2, we have 4, 1s and 3p. And the third energy level, we have total of 9 orbitals, 1 plus 3 plus 5. And in the fourth energy level, we have 16. 1, 3, 5 plus 6 is 16. And with regards to the total number of electrons per sublevel, Ns, we always have 2. In P, we have 6. And in D, we have 10. And F, we have 14. And these are now the total electrons this is the total electrons in a given energy level. Do you understand, my dear students? Okay, let us now try to discuss what is electron configuration. Electron configuration of an element describes how electrons are distributed in its atomic orbitals. Electron configurations of atoms follow a standard notation in which all electrons containing atomic subshells are placed in sequence. Okay, then what about atomic orbital diagram? An orbital filling diagram is the more visual way to represent the arrangement of all the electrons in a particular atom. Again, arrangement of all the electrons in a particular atom. In an orbital filling diagram, the individual orbitals are shown as either circles or squares. Usually in my model a while ago, I use circles to represent the orbitals. In later part, you might see squares. Okay, each sublevel is labeled by its principal energy level and sublevel. Electrons are indicated by arrows inside the circles. An arrow pointing upwards indicates one spin direction, while a downward pointing arrow indicates also the other direction. Okay, let us have a sample electron configuration. This one class is the example of electron configuration. This is the electron configuration of potassium. Okay, then we have the sample orbital diagram. This is also the orbital diagram of potassium. Using this electron configuration, we arrive at this orbital diagram. So 1s, 2s, and so on. Okay, so are you now ready to learn how to write electron configuration and orbital diagram? Just continue watching and prepare a sheet of paper later on because you will be given a short quiz. Okay, class, let us first discuss the different rules in writing electron configurations. So usually we have 3 rules. We have off-book principle, we have Pauli's exclusion principle, and we have the Hans rule of multiplicity. Okay, let us discuss one by one. Okay, let's start with the off-book principle. Okay, off-book principle is also known as the building up principle, which states that electrons occupy orbitals in order of increasing energy, which means that in filling up electron configuration, we usually start with the atomic orbital having the lowest energy. Then it follows the electron distribution mnemonics in filling up the orbital. Okay, so this one is the electron distribution mnemonics. So the orbital which is the lowest energy is 1s, and it is followed by 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 4f, 6d, and 7p. So this is the arrangement of the atomic orbitals in order of increasing energy. Wherein 1s is the lowest energy and 7p has the highest energy. Now, in filling up the orbitals, we need to consider the total electrons that can occupy in its orbital. In S, it can be less than or equal to 2, P less than or equal to 6, D less than or equal to 10, and F less than or equal to 14. We only use less than 2, less than 6, less than 10, less than 14 if a particular configuration is the last configuration. Okay, do you understand, class? Very good. Okay, next. We have now an example of how to write the electron configuration following the electron distribution mnemonics. So, letter A, we have lithium having 3 as the number of electrons. So, how do we write the electron configuration? As the Aufbau principle says, we have to start with the lowest energy atomic orbital, which is 1s. It should contain 2 electrons followed by 2s, and it should contain only 1 electron because we only have 3 total number of electrons in lithium. And in sodium, we have 11 electrons. To write the electron configuration, again, we have to follow the electron distribution mnemonics. So we start from the lowest energy orbital, which is 1s, having 2 electrons, followed by 2s, again having 2 electrons, 2p, having 6 electrons, and 3s, having only 1 electron. That is to complete 11 electrons totally. Okay, then we proceed to the second rule, which is the Paulus exclusion principle, which states that electrons occupying the same orbital must have opposite spin. This is also, this can be shown in orbital diagram. So this one is the 1s orbital and this one is the 2s orbital. As you can see, in the 1s orbital, the 2 electrons are in opposite direction, one upward and one downward. And then in the 2s orbital, we only have 1 electron and it is to be upward. So you have to alternate upward and downward. So if we start with upward, you also start the second orbital with upward. Okay, some more example. We have here sodium having 11 electrons. So we have 1s, 2s, 2p, 6, and 3s, 1. So 1s, again, we have 2 arrows. 2s, 2 arrows. In 2p, you have 6 arrows, 2 each. And 3s, we only have 1 arrow. Okay? Then, let us have the third rule, which is the Hund's rule of multiplicity, which states that when electrons enter a sublevel with more than one orbital, they will spread out to the available orbitals with the same spin before pairing. So, meaning, when we distribute the electrons, if there are 3 orbitals for P, sa D we have 5 orbitals, and then sa F we have 7 orbitals. In distributing the electrons, we have to distribute one each before pairing, just like when you are playing a songka. Okay, like for example, here the nitrogen having 7 electrons. So this is our electron configuration: 1s2, 2s2, 2p3. Now in writing the orbital diagram, so 1s complete electrons, 2s complete electrons, and then sa 2p, since we only have 3 electrons, we have to distribute one each first. Okay? So this one now are some examples of electron configurations and the orbital diagram of the lighter elements. We have here lithium having 3, which is this electron configuration: 1s2, 2s2, 1s2, 2s1, and this is the orbital diagram. And beryllium, we have 4, 1s2, 2s2, so meaning 1s has 2 electrons, 2s has 2 electrons having opposite spin. And then boron, we have 5. This is our electron configuration: 1s2, 2s2, 2p1, total of 5 electrons. So this is our orbital diagram. For carbon, we have 6, and this is our electron configuration, and this is our distribution of electrons. And for nitrogen, we already discussed that a while ago. And then for neon, 10 electrons. So this is our electron configuration: 1s2, 2s2, 2p6. And this is how we distribute the electrons. All are filled. And then lastly, we have sodium having 11 electrons. We have 1s2, 2s2, 2p6, and 3s1. So from 1s to 2p, we have filled orbitals. And sa 3s, we only have 1 electron. Okay, do you understand, class? Very good. Okay, next. Okay, class, let us try this one. Oh, the instruction is write the electron configuration and draw the orbital diagram of the elements below. So we have here aluminum having 13 electrons and chlorine having 17 electrons. Okay, let us do it. Okay, so for aluminum, we need 13 electrons. So by using electron distribution mnemonics, it's just easy for us to write the electron configuration. Okay, let us start with 1s. Okay, of course, we have to write 2 electrons, then followed by 2s. Again, 2 electrons for 2s. And then next, we have 2p, which is 6 total electrons. And then followed by 3s, having 2 electrons. And then 3p must contain only 1 electron to complete 13. So if we will count, 2 plus 2 is 4, plus 6 is 10, plus 2, 12, plus 1 is 13. So this is the electron configuration of aluminum. Now in drawing orbital diagram, so you can write the orbitals below. You have 1s, you have 2s, then you have 2p, some distance because we have 3p orbital, 2p orbitals. And then we have 3s, and then we have 3p. Okay, so let's make a square which will represent our orbital. Then for 2p, we have 3 orbitals. Then we have 1s, and again we have 3p orbitals. Okay, now let us try to fill up the electrons. So 1s complete of 2 electrons, one upward and one downward. Same with 2s. Then here, distribute each before pairing. Okay, complete. And then we in 3s, we have 2, and then we only have 1 and 3p, so we have to write it in the first orbital, not in the middle, not in the last. It should be in the first orbital. Okay, so far this is the orbital diagram of aluminum, and this is the electron configuration of aluminum. Okay, then in chlorine, again we start from the lowest energy orbital, which is 1s, should contain 2 electrons. Then you have 2p, wrong, sorry. 1s, 2, then 2s containing 2 electrons, then followed by 2p, must have 6 electrons because this is p orbital. Then we followed by 3s, this one here, 2 electrons, and 3p must have 5 electrons to complete 17. So 2 plus 2 plus 6 is 10, plus 2, 12, plus 5, 17. So far, this is our electron configuration. And then write on making the orbital diagram, you write the orbital first. We have 1s, we have 2s, we have 2p, we have 3s, and of course, we have 3p. Okay, 1 orbital for 1s, 1 orbital for 2s, 3 orbitals for 2p, 1 orbital for 3s, and 3p orbitals. Okay, again, we have here filled with 2 electrons, so 1s. Same with 2s. And in 2p, also filled with electrons. And sa 3s, also filled with electrons. Whereas in 3p, we only have 5. So in distributing, we start with the first orbital, 1 each. Then it's time for you to pair if done distributing all. So since we only have 5, so we end up here. 1, 2, 1, 2, 3, 4, 5. Okay? Okay, so these are the orbital diagram and electron configuration of fluorine. Okay, by the way, any questions before we proceed? If you have a question and if you are watching the video in my YouTube channel, you can write your comment down below if you have questions. Okay, are rules important? If rules are important in writing electron configuration, rules are also important in our daily life situation. Okay, just want you to read this one, and everything that we do in life, we always follow certain rules. As a student, for example, you need to follow the rules imposed by the school. And as a daughter or son, you need also to follow the rules imposed by your parents. And in this time of pandemic, we also follow certain rules such as wearing a face mask and face shield every time we go out and when we are in group. In other words, if there are rules, we should follow. Okay, then to summarize, Okay, electron configuration is just an arrangement of electrons in a successive sublevels and atomic orbitals. In writing electron configuration, we usually follow electron distribution mnemonics. Orbital diagram, on the other hand, is a pictorial description of the electrons in an atom. Orbital diagram and electron configuration follow Aufbau principle, Pauli's exclusion principle, and Hans rule. Okay, now I think it's time for you. By the way, before I give you a short quiz, do you have any question and whatsoever? Okay, it's time for you to uh, answer our short evaluation. You try this one in a one-up sheet of paper. Write the electron configuration and draw the orbital diagram of the following elements. We have iron, oxygen, and calcium. Okay, you can answer this one for 5 minutes. You can pause the video while answering. Okay, you can start now. And finally, I hope you are done. Are you through, my dear students? Let's now check your work. Okay? Check your own work and be honest. Okay, for iron. Okay, for iron, so this is the electron configuration. We have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Okay, for the orbital diagram, we have in 1s2, electrons filled, one arrow down. Same with 2s, same with 2p, 3 orbitals are filled. 3s also is filled. The 3p orbitals also are paired. 4s also is paired. And in the 3d orbitals, since we only have 6, the second, the third, fourth, and fifth orbitals contain only a single arrow up electron, while the first one has pair. Okay, so you can check one here and another one here, or you can have 2 points, 2 points. Next, for oxygen, we have 8 electrons. So if you will write the electron configuration, we have 1s2, 2s2, and 2p4 to complete 8 electrons. Okay, then this is the orbital diagram. 1s, 2s are filled, 2p, since we have only 4 electrons, only the first orbital is filled with 2 electrons. Okay, again, 2 points here, 2 points here. And then the third one, we have calcium, which is 20 electrons. Okay, so this is so far the atomic, the electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. And the orbital diagram, we have it here, 1s, 2s, 2p, 3s, 3p, and 4s. And if you are correct, you can give this 2 points, another 2 points. All in all, we have 12 points. Okay? Did you get the correct answer, my dear students? Very good. Okay, for your assignment, I want you to answer these 2 questions. Number 1, what is valence configuration? And number 2, explain how is periodic table used in determining the valence configuration of an element. If you also have your old periodic table, you can kindly bring that also, or kindly use that in our next video lesson. Thank you so much, grade 9 students, for your time. I hope you'll learn something new from this video episode. See you again on my next video. Bye-bye!